Hi everybody, this video goes over section 5 of chapter 6, and in this video we will discuss the graph of the tangent and cotangent functions. In this video we will present the graph of the tangent function. Then we will present the graph of the cotangent function. Then we will present graphing techniques for both the tangent and cotangent functions. These techniques are not only used to graph these functions, but also to recognize the appropriate graph for the given function. And we will apply these techniques to the graph of the functions in the most general sense. Well, this right here is the graph of the tangent function. Recall that the tangent is equal to the ratio of the sine to the cosine. And to graph this, we are going to start at negative pi over 2. And at negative pi over 2, cosine is equal to 0 and sine is equal to negative 1. So we have something that's undefined, but it actually happens to be approaching negative infinity. As we go up to pi over 4, it turns out that sine and cosine have the exact same values, except sine is negative. As a consequence, the tangent is equal to negative 1. As we go to 0, sine is 0, cosine is 1, so the tangent is 0. As we go to pi over 4, both sine and sine have the exact same value and the exact same polarities, so we get 1. And then as we continue on, we go all the way up to, and as we continue to pi over 2, the equation becomes undefined as it approaches infinity. So this right here is the curve for exactly one period. And over here we have the same curve for 1, 2, 3 periods. So as you can see, this curve repeats at every pi interval. What else can we say about this function? Well, once again, the domain is all values of x for which the function is defined, and that is basically all values of x except odd multiples of pi over 2. And this is basically a mathy way of saying that we want odd multiples of pi over 2. This right here is an odd number, and that's pi over 2. The range, as you can see, is the entire real line. And once again, the graph is undefined for odd multiples of pi over 2. And as a consequence, we have vertical asymptotes at odd multiples of pi over 2. Notice that we have x-intercepts at all multiples of pi. And also what you can see is that this is an odd function. Also notice that the tangent curve has no maximum and no minimum. As a consequence, it has no amplitude. Also notice that it is symmetric about the origin. Therefore, it is an odd function and corresponds and follows this relationship. Now, the cotangent function, this actually should say cotangent, that's a typo, is actually the reciprocal of the tangent function. So wherever the tangent function is undefined, like at odd multiples of pi over 2, cotangent is 0. Wherever tangent is 0, cotangent happens to be undefined. And so we can plot points for one period, and here we go. If we start, and here we're going to start when x is equal to 0, and when x is equal to 0, sine is equal to 0, so cotangent is undefined. When x becomes pi over 2, cosine and sine have the exact same values, so the tangent is 1. When x is equal to pi over 4, cosine and sine have the exact same values, so the tangent is 1. When x is equal to pi over 2, cosine is equal to 0. Sine is equal to 1, and we have 0. And then finally we have negative 1 for 3 pi over 4, and it becomes undefined as we approach pi, x is equal to pi. And as you can see, once again, we have a period of pi. It repeats every pi intervals. However, this graph is pretty much anti-symmetric. Okay, what else can we say about this graph? Well, here, the domain is all values of x except for integer multiples of pi. For integer multiples of pi, the function is not defined. Therefore, those values of x cannot be part of the domain. The range is the range basically is the entire real line. It can take on all values between negative infinity and infinity. And of course, the graph is undefined once again for all integral multiples of pi and has a vertical asymptote at each integral multiple of pi. The x-intercepts. The x-intercepts are at odd multiples of pi over 2, and once again the period is pi. And furthermore, the graph has no minimum or maximum values, therefore it has no amplitude. As far as the last 3 points here, they aren't exactly correct. because it is not symmetric about the y-axis. It turns out it is basically asymmetric about the y-axis, and therefore it's not an even function nor an odd function. Okay, now in dealing with graphing tangents and cotangents, there are 5 important points that we want to pay attention to, and that is where the value of x where we have a vertical asymptote, the value of x where tangent is equal to -1, which is negative pi over 4, the value of x where it's equal to 0, or it's equal to pi over 4, and also where the vertical asymptote is. And you'll notice that this point right here is the midpoint. This point right here is what we would call the first quarter, and we usually just abbreviate that as 1q. This is the third quarter, and of course these two are the asymptotes. Similarly, for cotangent, if we need to change that as well, cotangent, we have the 5 important points as well, and they are basically the same, although shifted a little bit. Once again, we have the asymptotes. This right here is the midpoint. This is the first quarter, and then this is the third quarter. And essentially what we want to do when we plot tangents and cotangents, even if they're scaled in certain ways, we want to find the appropriate values for the asymptotes, use that to find the midpoint, which will be midway between the asymptotes, and then we want to find the first and third quarter, which is midway between the midpoint and the first vertical asymptote for the first quarter, and midway between the midpoint and the second vertical asymptote for the third quarter. If you've ever taken stats and did Box and Wistar plots or found quartiles, we're doing pretty much the exact same thing. And this is our procedure for finding, for not only graphing tangent and cotangent functions, but also for finding the points that we need to determine which graph is the correct tangent and cotangent function. Because in your homework, you're not going to need to graph functions, but you're going to be given a collection of graphs, and you need to find the graph that is appropriate for that particular function. Okay, now to graph these, what we need to do is we need to first find the period, and that is going to be equal to pi over b, since the period for tangent and cotangent is pi and not 2 pi. Once we've done that, we want to locate the 2 vertical asymptotes, and that can be solved for tangent by taking the argument and setting it equal to negative pi over 2 and solving for x, and then taking the argument and setting that equal to positive pi over 2 and solving for x. One thing that you'll notice is that once you find the left asymptote, the lower vertical asymptote, all you need to do is add the period to it, to find the higher asymptote. For cosine, for cotangent, we need to find the left asymptote by solving this equation. That's pretty straightforward, and also by solving this particular equation. Once we have found those, we want to sketch the 2 vertical asymptotes and divide the interval into 4 equal parts. When we do, we will have the asymptotes. We can call the first asymptote V1. We will then have the second asymptote, which is XV2. We can then define, we can actually break this into 4 equal intervals by finding the midpoint, XM, then finding the first quarter, I'll call that XQ1, and then finding the second quarter, of course, or the third quarter, which will be XQ3. So that's pretty much what we're doing. Once we found these points, we want to evaluate the tangent or cotangent at those points. And once you've done that, you can either plot the points or use this information to determine the correct graph. Okay, well, let's see how this works in an example. And this is our first example. Now, the first thing that we want to do is we want to find the period. The period, which is t, is going to be equal to pi divided by b, which in this case is 2/3. And the answer is going to be, and then we will get 3 pi over 2. That is the period. So let me put that over here. T is equal to 3 pi over 2, or 3/2 pi. Once we've done that, we need to find the first vertical asymptote, and that is going to be b times x is equal to negative pi over 2. Okay, well, b is 2/3, so that will be 2/3 times x is equal to negative pi over 2, or that x is equal to negative pi over 2 times 3/2, which will give us negative 3 pi over 4. Okay, so we have our first vertical asymptote. I'm going to call that xv1 is equal to negative 3 pi over 4. Well, remember here that the next vertical asymptote is going to be one period beyond that, so we could actually compute that by taking negative 3 pi over 4 and then adding 3 pi over 2 to it, which by the way would be 6 pi over 4. That would give us positive 3 pi over 4. That would be our next vertical asymptote. If you don't believe it, what you can do then is go ahead and solve bx for positive pi over 2, and yes, positive pi over 2, and yes, you will get that xv2 is indeed 3 pi over 4. Okay, so xv1 is negative 3 pi over 4, and xv2 is equal to positive 3 pi over 4. Okay, so with that in mind, we can actually already begin to eliminate some graphs. This one has an asymptote at 0 and an asymptote at 3 pi over 2. Can't be this graph. This one has an asymptote at x equals 0 and an asymptote at x equals 3 pi over 2. Can't be this one either. This one has an asymptote of negative pi over 3 and one of pi over 3. It can't be this one. This one has an asymptote at negative 3 pi over 4 and positive 3 pi over 4. It is most likely this one. Now, it would be good to go ahead and, at least for purposes of practice and illustration, to compute the 3 important points. The first one is the midpoint. I'm going to call that xm. The midpoint, that was pretty bad. The midpoint, xm, is going to be halfway between negative 3 pi over 4 and positive 3 pi over 4. And of course, that would be 0. Okay? The first quarter, which I'm going to call x1, well, that's going to be halfway between 0 and negative 3 pi over 4. That will be negative 3 pi over 8. And then the second quarter will be positive 3. The third quarter will be positive 3 pi over 8. Evaluating this function at the first quarter, we are going to have that y1 is equal to the tangent of 2/3 times x, which is negative 3 pi over 8. That is going to be the tangent of negative pi over 4, which is equal to negative 1. For the midpoint, y sub m would be equal to 0. The tangent of x is 0. The 2/3 x is 0. Tangent is 0 is 0. And then finally, y sub 3 would be equal to positive 1, which of course would be this point, this point, this point. This is the graph. Okay, here we want to graph 3 times the cotangent of 1/2 x. First we want to find the period. The period is going to be equal to pi divided by b, which is pi divided by 1/2, which will be equal to 2 pi. So t is equal to 2 pi. The first asymptote can be found by solving 1/2 times x is equal to 0, which by the way will give you that xv1 is equal to 0. That's the first vertical asymptote. The second vertical asymptote will be one period away, which will be 2 pi. So the next one will be xv2 is equal to 2 pi. And of course, if you wanted to, you could solve 1/2 x is equal to pi, and yes, you would get 2 pi. Okay, so here we have our asymptotes are 0 and pi over 2, so this can't be it. This one has asymptote from 0 to 2 pi, so this is a possibility. This one has asymptotes from negative pi to pi. That can't be it. This one has an asymptote at 0 and 2 pi, so The first one and the fourth one are possibilities. Okay, so now with that in mind, we need to go ahead and compute the midpoints. Okay, or compute the midpoint, the first quarter, and the third quarter. Well, the midpoint, x of m, is going to be halfway between 0 and 2 pi, which will be pi. x1, the first quarter, is going to be halfway between pi and 0, which will be pi over 2. And then finally, the third quarter is going to be equal to 3 pi over 2. The tangent of 1/2, the 3 times the cotangent of 1/2 times pi over 2 is going to be 3 times the cotangent of 1/4, or pi over 4, which will be equal to cotangent of pi over 4 is 1 times 3 gives us 3. So we have y1 is equal to 3. y2, cotangent of pi over 2, will be equal to 0. And then finally y3, cotangent of 3 pi over 4, is going to be equal to negative 1 times 3 is negative 3. And which graph are we talking about? Well, here at pi over 2, we have 3, which are what we're looking for. 0, negative 3. This is the graph. This is not the graph. Okay, next we have the graph of y is equal to negative 3 plus the tangent x. Okay, in this particular case, well, you can almost guess what this is. You just take tangent of x and shift it down by 3. Okay, well, right here is tangent of x, and notice that we are shifted down by 1, 2, 3. So actually, this one would be the graph. You can actually see it right away. But let's go ahead and actually figure out some parameters. First thing is that the period is equal to pi. Okay? The first asymptote can be found by setting x equal to negative pi over 2. Hey, there it is equal to negative pi over 2. And the next one is going to be positive pi over 2. So the first asymptote, xv1, is equal to negative pi over 2. And then xv2 is equal to positive pi over 2. Okay, if that's the case, then the midpoint, xm, is equal to 0. The first quarter, x1, is equal to negative pi over 4. And the third quarter, x3, is equal to positive pi over 4. When x is 0, tangent is 0, minus, and you subtract 3 from that, we have that ym is equal to minus 3. When x is negative pi over 4, tangent is negative 1, minus 3, we have y1 is equal to minus 4, and y3 will be equal to minus 2. And which one has that for us? Well, it's this one right here. Minus 4, minus 3, minus 2. This is the graph. This is not the graph. This is not the graph because it's a plot of a cotangent, and this also is not the graph because it is also a plot of a cotangent. And that brings us to a more generalized formula for the case where we actually have a vertical shift and a horizontal shift. And there really is no difference. It is pretty much the same procedure. The only difference is to find the asymptotes. I probably should have started off with this. We once again set the argument of the tangent or cotangent function, or for the tangent function, equal to negative pi over 2 to get the left asymptote. And then if we want, we can add the period to that to get the right asymptote, or we can just go ahead and solve this equation. And then for cotangent, to find the left asymptote, we just set the argument equal to 0 to find the left asymptote, and then we set the argument equal to pi to find the right asymptote. Then we can sketch the asymptotes, find the midpoint, first quarter and third quarter, evaluate the function at those points, and then we can either plot the graph or, in our case, recognize the graph. And we can do that with this example. So here we have negative 3 plus 2 tangent of 3/4 x minus pi. Now, one of the things that we can do is rewrite this as negative 3 plus 2 times the tangent. We can factor out the 3/4, and then that'll be multiplied by the quantity x minus 4/3 pi. And the primary reason why we want to do this is to highlight that this actually is the angular velocity or angular frequency, which we can use to compute the period. Now to compute the period, once again, this is b. We just want to compute, we know that the period is equal to pi divided by b, which in this case is going to be pi divided by 3/2, which will give us 2 pi divided by 3. Okay, so that's our period. Our first vertical asymptote can be found by solving the equation where we set the argument equal to -pi/2. Now we can set this value equal to -pi/2, or we can set this value equal to -pi/2. They're both the same value. It's just one has a factored form. So let's let 3/4, positive 3/4, x minus pi be equal to -pi/2. Okay, if we do that, we can add pi to both sides, and then we will have 3/4 x is equal to -pi/2 plus pi, and then that will give us that 3/4 x is equal to positive pi/2, and then multiplying both sides by 4/3, we will have that x v1, the first vertical asymptote, is going to be equal to pi/2 times 4/3, and that will give us 2 pi/3. Okay, so this is x v1. Now remember, the second vertical asymptote is one period away from that one. So x v2 is going to be equal to 2 pi/3 plus 2 pi/3. Well, it looks like I made a mistake computing the, I definitely made a mistake computing the period. Notice here that the period, I'm going to do it down here, that the period is equal to pi divided by b, and I mistakenly wrote b as 3/2, b is 3/4. So this should be equal to pi divided by 3/4, which will be equal to 4 pi/3. That's kind of important because I want to add 4 pi/3, one period over here, and that will give me 6 pi/3 or 2 pi, which is actually what I was looking for. Now to verify this, we can actually go ahead and solve the associated equation, and that will be the argument, which is 3/4 times x minus pi is equal to pi/2. And of course that will become 3/4 x is equal to 3 pi/2. And then x will be equal to 3 pi/2 times 4/3. And of course these cancel. This reduces to a 2, and we have 2 pi, so it does indeed work out. Okay, so we have our first vertical asymptote is 2 pi/3, and the second vertical asymptote is 2 pi. Here we have 2 pi/3 and 2 pi, cool. Here we have 2 pi/3 and 2 pi. Here we have 0 and 4 pi/3, so this cannot be one of the graphs. Now to figure out which graph is correct, we can then look at the first quarter, the midpoint, and then the second quarter. Well, if our asymptotes are at 2 pi/3 and 2 pi, then the midpoint is going, which by the way is 6 pi/3. The midpoint is going to be at 4 pi/3. So xm 4 pi/3. That means that our first quarter is going to be at pi, 3 pi/3. And the third quarter is going to be at 5 pi/3. At the midpoint, the tangent is going to be equal to 0. Multiply that by 2, you still get 0. Subtract 3 from that, we have that the midpoint at y is equal to -3. Okay, the midpoint of the value at the first quarter, well, that's going to be the tangent of pi over 4. Negative pi over 4, my apologies. And that will be negative 1 times 2 is negative 2 minus 3. We will have that y at the first quarter is negative 5. And then finally, y at the third quarter will be equal to negative 1. And with that, we have everything we need to figure out which plot is correct. Now, coming over here, notice that at pi, which by the way is the first quarter, we should have negative 5. Here we have positive 1, so this can't be it. Over here at the first quarter, we have negative 5. At the midpoint, we have negative 3. And then over here at the third quarter, we have negative 1, so this is the graph. So by computing these points right here, although it's a little dirty, sorry about that, and then computing the asymptotes, we can figure out which graph is indeed the correct graph. Now, the last thing you're going to find yourself doing in this particular homework is trying to figure out the equation from a graph. So here is a graph. Notice that the asymptotes are 0 and 2 pi, namely we start at 0. So this looks like a cotangent. Furthermore, the period t is equal to 2 pi, which is going to be equal to pi divided by b, which is the argument next to the x, or the coefficient of the x. So if that's the case, we have that b is equal to 2. Okay, so we will have cotangent of 2 times x. Now also recall that the cotangent is positive here and goes down like this. So this actually is a reflection of that cotangent. Also notice that at the midpoint, the cotangent tends to be equal to 0, and then at the quarter points, they tend to be equal to 1. So this looks like we actually have a vertical shift, and we do, of 1, and that actually is our equation. Y is equal to 1 minus cotangent of 2x. What about this one? Well, this looks a lot like a tangent function. Also notice that it basically spans from negative pi over 2 to pi over 2, which is one period, and which is a period of 2 pi, which is the period of a tangent function. So there is no coefficient, so we can just go ahead and write this as tangent of x. Now also notice that when x is equal to 0, tangent is equal to 0, so there's no vertical shift. However, when x is equal to negative pi over 4 or positive pi over 4, we have 3. So there is a multiplication factor going on, or a stretching, and that would give us a 3 here, and our answer would be y is equal to 3 times the tangent of x. And that would be our answer. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.